Okay, so uh, good evening to everyone who has joined. Thank you for joining. For those who don't know, my name is Rushi. I am based in the US, and at Jeavio, I look after our startup portfolio. I do a lot of advisory work with our friends in our various startup portfolios, and also do a lot of work with BTS. I have been with Jeavio for about 3 years, and my background is in doing a lot of backend development. Before joining Jeavio, I was the CTO of an very early stage startup that had worked with Jeavio. I'd done some work on machine learning and NLP, and before I joined the startup world, I worked in banking, doing algorithmic trading, models, technology stuff for almost 13 or 14 years. My passion is technology. I spent too much time maybe messing around and doing research around technology, and I put together this session as a way of talking about this interesting world of Web3 and crypto and so on. Obviously, there's been a lot of hype. There's been a lot of information flowing around. There's a lot of money in this space. So I thought it would be a good way today to talk a little bit about this crazy world. It is not going to be a very technical session. I'm trying to cover a lot of ground here and try and keep the session to about 50 or 55 minutes. So it is going to be a very surface level presentation, but my intent here is to give you all an overview and a map of what is happening in this space, and maybe give you some pointers for further research. We are going to cover a good amount of material. I'll start with a little bit of a philosophical approach around money. We'll talk about Bitcoin, we'll talk about Ethereum. We'll then take a step back to see how everything fits in the context of this Web3 paradigm. And then we are going to go a little bit deeper into some specific items. We're going to talk about DAOs, distributed or decentralized autonomous organizations. We're going to talk about decentralized finance. We'll talk about NFTs, and then we'll end with some discussion, some thoughts, my thoughts around what it means to be building in Web3, and where I see things going. I also have some further reading for those who are interested. You can find the PDF on our engineering channel. Please take a look. And if you have any questions while we're going through, what I suggest is please put them into the Zoom chat, and I will try and address as much as I can, or hopefully give you a pointer to some other material if required. Okay, so one thing I just want to make very, very clear is that although we are going to be talking about cryptocurrencies and so on here, none of what I'm saying should be taken as investment advice. I do, just to be clear, I do have some positions in cryptocurrencies, so I'm not a totally neutral observer. But if you are interested in this space, do your own research and don't take anything that other people tell you at face value. Okay, so for those who have sat through some of my presentations before, there are going to be terrible memes. So we already have one here. We have our famous Shiba Inu dog, the mascot of Dogecoin, which has been around for a while, right? So just to give you a little bit of a spoiler, myself, I am a little bit of a skeptic in this space. I'm still trying to figure out what this all means. So you won't find a lot of very pro crypto propaganda in this presentation. Okay, So let's get started. So first things first, let's talk about money. Okay, so the first project that has really gained a significant amount of ground in the crypto space has been Bitcoin, and Bitcoin really came about as a means of digital money. So, but what does actually money mean? Okay, so money can be thought of a medium of exchange, right? So if I want to get some goods or services from you, I can swap my money for that. It can be thought of as a store of value, right? So this is where if I've earned some money, if I've done some work, the value that I have generated can be stored in money that is in my bank account or under my bed or whatever. You can think of money as an enabler of economic activity, right? So before we had money, if I wanted to trade, let's say if I wanted to trade with somebody who is very far away from me, right? Let's say I'm living in coastal Gujarat and I want to trade for some diamonds that are coming from thousands of kilometers away, which are getting to Gujarat via a small boat from the south of India, right? Before money, we might have had a barter system where I say, okay, well, for your diamonds, I'll do you some work. But but when the origination of the good is so far away, how is a barter system going to work, right? So money is an enabler of economic activity because it can be a way in which I can pay for goods and services with someone who is not the initial originator of that good and service. Okay, so money has taken many forms in the past. Of course, we have these shells, cowrie shells were one of the first types of money. We had gold, which remains money. We have, of course, the US dollar and so on. One of the most interesting things about money is that it has been a driver for a lot of human cultural activity for many, many years. So what you see here, this tablet here is one of the first examples of writing that has ever been found. So this is a tablet. It's made in clay. It is from the Sumerian civilization. Sumerian civilization was in what is now modern day Iraq. And the funny thing about this tablet is that it doesn't contain information. It's not some prayer. It is not some great poem. It's not some epic journey. It actually is a ledger. It's a bill. What we understand what this tablet says is somebody owes me some money because I gave them 5 pigs and 2 pots of oil or something like that, right? So the first written history, like the first written artifact in human history is actually a ledger, and it actually is about economic activity, right? So before we dive into Web3 and crypto, one of the things I want you all to think about is this is not a purely technological discussion. This is a discussion that is at the intersection of technology, at the intersection of economics. It is at the intersection of culture. So that's why when you try and read about Bitcoin or Ethereum or any of the crazy crypto stuff that is going on right now, it has a very strong element of politics, about culture, about economics. Okay. So the next thing I want to talk about, which is very important here, is a notion of trust and trusted intermediaries, right? So when you get paid, your money isn't given to you in a stack of gold coins or in a stack of notes that you put in your backpack. It is actually deposited into your bank. So bank in this case is what we call a trusted intermediary, right? So it acts as an intermediary between Jeavio, between the company that you're working for, and between yourself. Both of you trust that the bank will keep your money safe and that when you want to withdraw the money, it is going to be available. So the modern financial system, it has been built on the top of trusted intermediaries, right? So when you use your credit card to buy something, there is a chain of trusted intermediaries that are taking part in the transaction. It might be the payment processor, MasterCard, Visa. It might be the issuing bank, wherever you've got your credit card from. And the bank, so there's a whole chain that sits between the vendor that you're buying the stuff from and yourself, okay? So this, this of course has enabled amazing amounts of economic growth and activity, but it also puts in some friction in terms of the way that you can do business. So if you want to now buy something from someone who is not in the same country or same jurisdiction as you are, you have to jump through a lot of hoops. Things are a little bit easier now, but even a few years ago, we had to deal with a lot of pain in order to move money from one country to another, right? Even now, if you want to onboard a new vendor, there is a whole process which might involve know your customers, might involve money laundering and so on. All of these things are here for a good reason. But the point to note here is that when you have a trusted intermediary or any sort of intermediary in a transaction, there is always going to be some friction. Also, these intermediaries tend to charge a tax or a fee in order to do your transactions, okay? So let's keep that in mind. Similarly, one of the things that a lot of you who have been following this, there's a lot of discussion about fiat money, right? So fiat money basically means the money or currency that is issued by a government. So the fiat money or currency for India is a rupee, for the US is a US dollar. So this is an example of centralization. And it also allows, when you have a government who is controlling the money supply, it could be through a central bank, of course. It also allows for things like capital controls. It also may lead to things like inflation. Okay, so for those who are following current economic trends, there is a lot of worry in the US, especially about inflation. So inflation means that the price of something tomorrow is going to be higher than the price of something today, right? So the reason why this is happening is because when a government controls the money, they have the ability to inject more liquidity into the system. They can generate money out of thin air, and that may lead to all kinds of weird consequences, such as inflation and capital controls and so on. For those who are maybe my generation, you all might remember that India also went through a pretty painful currency crisis in the early 90s when Manmohan Singh was the finance minister, and we had to really tighten up fiscal discipline, which involved changes in interest rates and monetary policy, which caused some short-term pain, but also was very beneficial in the long term. Similarly, another more recent example of the problems when you have a centralized control over money is what happened in the demonetization issue, I guess 3 or 4 years ago, right? When the government controls the supply of money, they have a lot of control over the economy, and you sort of lose control, or in theory, you lose control over your own destiny of how your money is being spent, okay? So I'm not gonna argue too much about the politics behind it, but I just wanted to give you some background of why this whole notion of cryptocurrencies and Bitcoin came into being, okay? So let's move on quickly then to Bitcoin. So Bitcoin, as you know, is one of the oldest cryptocurrency, but interestingly, it is not the first electronic currency. There were actually a bunch of other people who have tried having electronic currencies. There was the likes of Zcash and so on, but Bitcoin was the first one that has really taken off. Okay, so Bitcoin was created partly as a technological project, but also partly as a libertarian or political movement, where they said that I want to be able to have transactions without having intermediaries. I want to be able to have control of the money or the value that I generate without it being beholden to a government or something like that, right? So the Bitcoin was, of course, created on the back of a white paper by somebody who called themselves Satoshi Nakamoto. We know that this person probably is not their real name. Nobody actually knows who Satoshi Nakamoto is, but it was actually conceived as an electronic payment system. So this, the core idea behind Bitcoin was to have a peer-to-peer electronic payment system which does not rely on trusted intermediaries such as banks or payment processors or governments. The vision behind this, and then in technology in general, there's a very strong libertarian political movement, which is all about saying, hey, technology can do what the government does for us. Why the heck do we need government, right? So out of this kind of political movement has arisen these type of, Bitcoin is one of these ideas that came out of this intersection of politics and technology. And Satoshi wanted to build a system that does not have a trusted intermediary. Okay, so you don't have a bank. So how can you actually trust that if I send money to somebody here, that they will actually, that transaction is actually going to go through? How can I actually trust that the transaction that goes through, I don't send the same money twice, right? If money is nothing but a digital bit, and digital bits or digital data can be copied indefinitely, then how can I make sure that I don't send the same data or same money to 50 different people? Okay, so this is known as the double counting problem. Okay, so in order to solve the lack of trust, in order to make sure that we do not have double counting of digital assets, Bitcoin used a number of very interesting technical innovations, right? So they use cryptographic proof to make sure that that we don't have this notion of double counting, right? So on the Bitcoin, and they came up with this idea of a public immutable ledger, so that there is clarity, so that these transactions, which basically involve moving Bitcoin from one person to another, can be validated, and we avoid some of the issues that require a trusted intermediary, right? So the way that they solved this was by having a consensus mechanism, right? So a consensus mechanism here means that when I say that I sent money to Alice, there is some way in which people can say, yes, that is actually true. Rushi did send some Bitcoin to Alice. He sent half a Bitcoin to Alice using the Bitcoin network. The way that this is done is that transaction is recorded on the public blockchain, on the Bitcoin blockchain. And once that transaction is recorded, it cannot be changed, right? So here we have, this is this idea of a public immutable ledger, okay? But then you could say, well, what if somebody can go back and just say that, okay, I'm just going to say that Alice then sent the money to Bob, and that way, if it is in the ledger, then it has happened. Well, Alice has actually not done that transaction, right? So you also need some way to prove that that transaction happened. So the way that this happens is the ledger works by a group of nodes, right? So these are also known as miners. When a transaction happens, this transaction is broadcast to all the miners that are in the Bitcoin network. The miners then solve complex mathematical puzzles, and the first miner that solves the puzzle gets the right to write that transaction onto the blockchain, right? So this solving of complex mathematical puzzles is known as the proof of work algorithm. So we don't really have time to go into a lot of detail. I have sent some links to the Bitcoin white paper for those who are interested. Take a look at it, right? The core idea is that all these transactions they're batched together into what is known as a block. Each block is then validated by these nodes or miners on the Bitcoin network. All of the nodes are doing the same computation, but the node that finishes the computation first gets an award of a Bitcoin for validating this transaction and recording it to the blockchain. So the protocol or the algorithm that underpins Bitcoin will generate a Bitcoin and give it as a reward to a miner that has finished, that is the first one to complete this mathematical puzzle, right? So this is how Bitcoins are generated. Miners also get some transaction fees when they actually record this transaction as a means of payment. Now, the complexity of this algorithm increases every time. So the amount of energy or the amount of computing required goes up as time goes by. So all of this is encoded in the Bitcoin algorithm, right? So without going into too much detail, let's just talk about what it enables. So it has enabled consensus through a proof of work protocol in a trustless environment. Nobody knows, I don't need to know who Alice is. I just need to know her address on the Bitcoin network so I can send her some Bitcoin. There is no other, and everything else is done within the Bitcoin network itself, right? There is no other intermediary, there is no clearinghouse, there is no bank, there's nothing like that. And the only thing that Bitcoin actually enables is transactions. Bitcoin is a very, very simple system. The only thing that Bitcoin enables is transactions in Bitcoin. So it's kind of like a snake eating its own tail, right? Bitcoin, the whole Bitcoin network was created to generate Bitcoins and then transfer Bitcoins from one address to another. That's it, okay? So this took off. Bitcoin has been around now for almost for more than 10 years, and it's actually taken off. And Bitcoin has become quite interestingly, instead of people using Bitcoins to pay for electronic payments, Bitcoin has become more like digital gold, right? So if you think about the value of money, Bitcoin doesn't really enable much economic activity, but it definitely acts as a store of value. So we'll come back to this notion a little bit shortly, okay? So let's talk about Ethereum. So Ethereum was conceived maybe 5 years after Bitcoin was. One of the main features of Ethereum is that it also enables transactions. Instead of Bitcoin, the token of the Ethereum network is called Ether or ETH. And just like Bitcoin, it also uses currently a proof of work algorithm in order to validate transactions. However, the critical difference and the reason why Ethereum has really enabled this whole concept of Web3, this whole concept of decentralized computing, is because it's not just a ledger. It's not just a way in which to record transactions of moving Ether from one account to another. It actually defines itself as a single global computer, right? So for those who have done any sort of Java programming, we understand the concept of the Java virtual machine or the JVM. The JVM is basically a virtual computer. You can run programs on the Java virtual machine, which are written in bytecode. And that bytecode can be compiled from a bunch of different languages, Java, Scala, Groovy, whatever. And that code runs on the JVM. The JVM basically acts as a virtual computer, which is in turn deployed onto your actual computer. So similarly, the breakthrough for Ethereum is this notion of the Ethereum virtual machine. Just like a Java virtual machine, it is a virtual computer that runs on a series of nodes. These nodes are the miners. These nodes are also known as the Ethereum network. Okay, so what happens is that these nodes actually store not just transactions, but they also store the state of the virtual machine, right? So state of the virtual machine means what programs are running, what data is being run by these programs. So you can think of Ethereum as not just a ledger, an immutable ledger for transactions, which is of course there, just like Bitcoin, but the advance or the kind of breakthrough from Ethereum is the ability to execute code on top of the Ethereum virtual machine. Okay, so what it means is that it is programmable. So actually, the Ethereum virtual machine, I believe it is Turing complete. So what that means is that you can pretty much write any type of code and that can be executed on top of the Ethereum virtual machine, right? The coding language is known as Solidity. It is actually quite similar to JavaScript for those who know what this is. So what this means is you can write a program and you can deploy it on the Ethereum virtual machine. That program can take input, and the input on the Ethereum virtual machine basically is the contents of the ledger, right? and you can run some logic on it, and you can write some output back onto the Ethereum ledger, right? So the way to think about it is that the execution of each program on the Ethereum virtual machine is also a transaction, which results in the change of state on the Ethereum blockchain. Okay, so what happens here, like the breakthrough here, that is you can write all kinds of logic, and you can have it run on the Ethereum virtual machine, and you can have the results of this available to anyone who has access to the Ethereum network. Okay, so I just want to point out one thing here. So when we think about this distributed computing in the traditional sense, right? So let's say you have built an application, let's say it's Instagram. Instagram backend is deployed onto some sort of cloud computing backend. Let's say it's deployed on AWS. And when you make a request on your Instagram mobile app, it can be distributed between multiple different backend servers, right? So you probably have a load balancer, the request comes in, and the request will then be distributed to one of many nodes, right? So this is distributed computing. This is what we do every day. This is our normal way of working. Now, one thing to keep in mind is for Ethereum, what happens is that you have a network of nodes here. And when a transaction is done, each node, right, each node in the Ethereum virtual machine is doing the same computation. But only one node, i.e. the node that finishes the proof of work algorithm first, gets the right to write the results of the computation onto the blockchain. Okay, so this is not distributed computing. Each node is basically doing the same work, but it's a race. The node that can finish the proof of work algorithm the fastest, the first, is the one that gets a right to write the transaction to the blockchain, and then it gets rewarded the token, right, which is ETH. So this is something that it took me a little bit of time to figure out. But this is a very important concept, because what it means is that there is a huge amount of redundancy that happens in Web3 or distributed computing, right? And this is one of the big criticisms that we will come to shortly. Okay, so let's do a quick discussion of Web2 versus Web3, right? So Web2, there's of course Mr. Zuckerberg here, where we have basically centralized applications. Google manages your identity. Infrastructure is managed by AWS, storage might be somewhere else, and so on. On Web3, everything is decentralized. The network provides the infrastructure. So the nodes that we talked about, they are the ones that are providing all the infrastructure. There is no single owner of a decentralized network. However, there are some issues. So if somebody wants to Google, there is something called a 51% attack. So when somebody can control the majority of the nodes in a network, the majority of the nodes of the network, then you can have this issue. So Web2, a handful of powerful companies mediate our online experience, so Facebook and so on. The experience is mediated by the protocol, right? So the way that the protocol works, the way that applications work is defined by the way that the protocol is defined, right? So there are some applications that are deployed on the Ethereum blockchain can only work in a certain way. So the most important commodity for most Web2 companies is what we call user data, right? Facebook is free, but actually they monetize your data. Same thing for Google, same thing from Snapchat, a lot of these Web2 companies. Incentivization on Web3 is usually by the network token. So if you want to do a transaction on Ethereum, you need to pay the token, which is ETH. If you want to do a transaction on Solana, which is another blockchain, you pay the token, which is SOL, right? So there's a very clear way in which computing is incentivized. There can be single points of failure in Web2. So all of us probably are aware of outages on the likes of AWS that take down significant amounts of compute capability, right? In theory, blockchain applications are more resilient, because as long as there is one node here, then the network can remain active. A very, very big advantage of existing way of doing computing is that it is much higher performance, it is very cheap, and it's very, very fast. Code that runs on the blockchain, because of what we've discussed a little bit before, it is much lower throughput, and it is expensive because every single transaction requires some sort of transaction fees, and the more transactions you do, the higher those fees get. Okay, so Rushi Tucker here had asked, okay, what are the limitations of blocks on Bitcoin versus Ethereum? One of the limitations on both actually are that you are relying on nodes to do these transactions. And let's say in Ethereum, I think they write a block every 15 seconds, right? So it means that every transaction that is broadcast, they batch up the transactions in 15 seconds, and then those transactions are written onto the blockchain. Now, there are usually a lot more transactions than possible to be put into a single block. So what happens is that effectively each transaction will say, okay, I want to incentivize a miner to add my transaction into the block, so I'm going to pay a fee. Now, this fee is not fixed. This fee can increase, right? So these are known as gas fees. So what is happening now is as more and more transactions happen on the Ethereum blockchain, the fees keep going higher and higher because people are saying, okay, well, if I pay X amount of ETH and my transaction is not getting included in the block, okay, I'll pay X plus 1, X plus 2, right? So what happens is that these fees keep getting higher as the popularity of the blockchain increases, decreasing the throughput overall. Now, between Bitcoin and Ethereum, Bitcoin is even more restrictive. It is even slower than Ethereum because the number of transactions that can go into a block are lower, and the rate at which new blocks are written is also much lower in Bitcoin than Ethereum. Now, newer blockchains, so Solana, Algorand, these claim to have much faster transaction times, and they also use different ways of consensus mechanisms, such as proof of stake, right? So I think Dennis has also asked, saying, can you explain why all nodes start computation for same transaction, and what about energy? So yeah, that is exactly the point. The idea is that every node is doing the same transaction. The node that finishes the proof. So the way to think about it is that in order to write a block to the blockchain, you need to solve a puzzle, right? So transactions are broadcast. They are captured into blocks. So each node will record the transactions that are happening. It'll put it into a block. Then it'll trigger the computation, the proof of work algorithm. And the first node that can finish the proof of work algorithm, generally it means generating a number or a hash with very specific characteristics. So the node that is the fastest to generate it can write the transactions that it has captured into the blockchain. And the idea is that the node that writes the transaction first generates the longest blockchain, right? Because it is the one that has written the new block first, pointing to the previous block, and that now becomes a system of truth. Okay, so I would, there's a lot of material that we're going to cover. Dennis, I'll share some more material that goes into the philosophy behind this a little bit more. Now, but the reason why this is a big issue is that obviously a lot of nodes are doing redundant calculation, and then each proof of work requires a significant amount of energy to calculate, right? So that is where the whole energy discussion for crypto comes into play. So I don't think I did a good job answering this, but we can have a follow-on discussion here. Rajendra asked, is it correct that the mechanism for storing the ledger is different for Bitcoin and Ethereum? Yeah, they have different protocols. I would actually recommend anyone to read both the Bitcoin white paper and the Ethereum white paper. Actually, Ethereum has very good documentation that goes into detail of both how the ledger works and how the proof of work consensus mechanism works. So yeah, they have different underlying protocols. Bitcoin is actually a lot simpler than Ethereum is. Okay, so let's talk a little bit before we go on to the next part of the presentation. Let's talk a little bit about some of the terms that we have come across so far, or some of the terms that we will refer to. Okay, so blockchain or distributed ledger, I think we already talked about this. So it is a distributed, public, unchangeable database. And the data that is usually stored is in form of transactions. These transactions may also include the results of computation that is performed on the blockchain, right? A wallet. So another thing that is very important to think about here is that a wallet, when you think of your wallet, you think of a wallet, it has some notes or it has your credit card or whatever. A wallet in the context of crypto is basically an application or a device, actually. You can get hardware wallets that is storing the private keys that allow access to the blockchain. The money, the token, the Ethereum, Bitcoin, Solana, whatever, the money only remains on the blockchain, right? The concept of Ether or Bitcoin is limited in the world of the blockchain. It doesn't exist outside of the blockchain, right? So what a wallet gives you is access to your account on the blockchain, right? So for those who have some knowledge of cryptography, you have a private key and you have a public key, right? So the way to think about it is your account on the Ethereum blockchain or on the Bitcoin blockchain is a public key that corresponds to your account on Ethereum or on the Bitcoin blockchain. But in order to access it, you need a private key, and you store your private key in a wallet, right? So that's why you often hear these stories where somebody has lost their wallet, and then suddenly, even though they have thousands of Bitcoin available, they cannot access it because you need the private key in order to access the data on the blockchain, okay? Consensus mechanism is just a way in which nodes can validate transactions. Proof of work is currently used by Ethereum and Bitcoin. The one way to think about proof of work is one CPU equals one vote. Basically, what it means is that the miner that has the most powerful machine is the most likely to be able to validate transactions and solve these mathematical puzzles faster and generate more Bitcoin, okay? Proof of stake is something that is new. Actually, this is going to come to the Ethereum blockchain this year, next year in 2022. And the idea here is that instead of doing mathematical puzzles, the likelihood of you being able to validate a transaction depends on how many tokens you already have, right? So the way to think about it is that in a proof of stake environment, I want to become a node or a miner. And if I have, and if Rajendra also wants to become a miner, if I have 500 Ethereum that I've staked, and if Rajendra has 1500, then it is more likely that he will be able to validate the transaction than I am. So it is weighted by the amount of tokens that you can stake on the network. It's like saying, it's more like one token equals one vote, right? So this is proof of stake. So this is a lot more energy efficient. We can talk, if people are interested, we can have a more detailed session on consensus mechanisms here, right? Okay, so what is a protocol? Protocol is basically a set of rules that governs the blockchain. So Bitcoin and Ethereum are actually protocols because what they define is a set of rules how transactions on the Bitcoin or Ethereum blockchain can happen, right? Similarly, Solana, Avalanche, Algorand, all of these other protocols, all of these other ideas are basically protocols that define how transactions happen on those particular blockchains, okay? What is a smart contract? So a smart contract is code that is deployed to and executed on the blockchain. The code is actually public. Anything that is on the blockchain is public. Anybody can see it, right? And the execution basically will involve running the code, will involve some sort of transaction piece, okay? So this is another very important concept. Everything that you do on the blockchain, on a public blockchain, like Ethereum, is public, right? Although it might not say that this is Rushi's account, but the address of the account, the public key of the account is available for anyone to see. Anyone can see how much Ether I have in my public account. If I deploy a smart contract onto Ethereum, anyone can see the code, right? So one of the things to really keep in mind here is that this is fundamentally a different way of doing computing to what we're used to. And the flip side of this is that if you deploy a smart contract that is doing something about moving moving some tokens from your account to another account if a set of conditions is met. Anybody can analyze that code and find flaws in that code, which allow them to execute the smart contract and divert money or tokens to somewhere else, right? So when you read in the news that there was a hack, some smart contracts was hacked, actually that is not correct. What happened is that somebody analyzed the code and they sent some parameters to the code, which allowed the code to run in a certain way that was not originally defined by the people who wrote the code, right? So one thing to keep in mind is that any code that goes onto a public blockchain is public by definition. Okay, so a distributed app actually is a catch-all term. The way to think of a distributed app is a smart contract or a group of smart contracts put together with a user interface that allows somebody outside of the blockchain to be able to interact with the code. Okay, so it's a very catch-all term. There isn't really specific definition for it. Okay, and then tokens. What is a token? A token refers to an asset that resides on the blockchain, right? So actually, if you think about it, Ethereum, Bitcoin, Solana, all of these are tokens. But an Ethereum token lives in an account on the Ethereum blockchain, right? But one Ethereum token is the same as any other Ethereum token. It can be interchanged, so also known as fungible, right? So Ethereum or Bitcoin are fungible. One Ethereum is the same as another Ethereum. However, there is also a way in which to define tokens that are unique, right? So there is a standard known as ERC 721, which allows for the definition of unique digital assets on the Ethereum blockchain. So we'll talk about NFTs shortly, but just one thing to think about is NFTs are basically bits or digital assets that are represented on the blockchain that are completely unique. One NFT or one ERC 721 token on Ethereum cannot be exchanged for another ERC 721 token. It is a unique digital asset that lives on the blockchain. Okay. So with that, let's talk something a little bit more concrete. Okay. So I'm going to cover some of these terms, and hopefully will give you some examples of how these things work. Okay. In general, a lot of what I'm talking about is going to be related to the Ethereum blockchain, but you can have DAOs, you can have distributed finance written on any of the other existing blockchains, right? So Solana, Avalanche, Algorand, bunch of other blockchains exist. You can do what we are discussing here on any of these blockchains. But for the intents of this presentation, I'm mainly talking about the Ethereum blockchain. Okay. So what is a DAO? So DAO is known as a decentralized autonomous organization, right? So it really is a way in which you can have a set of rules that define how decisions are made. These set of rules are deployed to the blockchain as a smart contract, right? And they're controlled by the organization members. So I'll give you an example. A good one is known as Flamingo DAO. For those who have the PDF in front of them, you can click it. It goes into details about it. What it is a group of people, or more accurately, it is a group of Ethereum accounts that have gotten together and they've said, okay, each one of us, so you have 100 people who are part of this organization, and each one of these people or accounts pools, or they put forward some of their ETH. And they say, okay, I'm going to put forward 200 ETH into the pool for my DAO, right? They are then, depending on how much ETH that they have given, they're awarded tokens, which are also known as governance tokens for the DAO, right? So it basically means the more money I put in to the company, the more shares I get in the company, right? That is a very simple model. And then what happens is that through, they build an app, they deploy a smart contract, which governs how decisions are being made. Quite simply, this application says, okay, we are going to vote. Somebody puts in a proposal that I want to invest in some NFTs. Okay, I want to invest in NFTs. Let's call them crypto punk NFTs. Okay, these are very famous NFTs. So I want to invest in NFTs. A member of the DAO puts together a proposal. All the other members vote using the smart contract, saying, okay, should we do it? Should we not? And how much money should we put into investing into buying this set of NFTs? The result of the votes is then binding, and then that they can then go and deploy the money that they've raised, which is this Ethereum, into whatever asset that they want to buy, right? So what has happened here is that you have decision making that is mediated by code, which runs on the Ethereum blockchain. And these guys have been early investors in a bunch of different NFTs. They've actually made a huge amount of money. But then you can have a DAO for anything, right? You can have a DAO for a charity. Let's say that you want to run a charity that looks after street dogs in Baroda. Okay, so 10 of you create a DAO. The DAO has a smart contract which is deployed onto Ethereum. All of the people who are part of the DAO, they stake some Ethereum and they get governance tokens. And then you have a vote saying, okay, how are we going to use this money? Should we build a shelter for the dogs? Should we have some sort of program to buy them food? Should we have some sort of program to pay for their medical bills? All of that can be voted. The vote is captured on the smart contract. It is recorded. It is immutable, remember. And then that decision has been made, and then that money can be deployed. Okay, so that is known as a distributed autonomous organization. You just think of it as a way of the blockchain mediating decisions and helping things move forward. Okay, next one. We're going to talk about decentralized finance or DeFi. Now, this is a real rabbit hole, right? And I don't think I can make justice to this field in a couple of minutes, okay? But the way to think about it is quite similar to distributed autonomous organizations. You can think of it as a term to describe financial protocols that are built on top of blockchains, right? So as we now know, Ethereum and a lot of other blockchains, not Bitcoin though, can enable code to run on the virtual machine, right? This code can be used to build apps, and these apps in DeFi, these apps we're talking about are mainly financial apps. So they allow things like peer-to-peer lending, trading, derivatives, and a whole bunch of different things, right? These services are deployed as smart contracts, right? And a really interesting one of the earliest DeFi, one of the most popular distributed finance protocols is known as Compound. Compound is really interesting. It allows, what it does is that it will automatically, it enables the lending and borrowing of cryptocurrencies. Okay, so what has happened? A lot of people have bought cryptocurrencies. They've bought Ethereum, they bought Litecoin, whatever, but they're not doing anything. As we know, most cryptocurrencies are bought as a store of value, right? So these cryptocurrencies are sitting in people's wallets and not doing anything. So the idea behind Compound is that, okay, how can we generate some return on these cryptocurrencies that people are sitting on? So Compound allows people to borrow and lend on the blockchain. And the interest rates that are set for interest rates that you earn for loaning out your cryptocurrencies, and the interest rate that you have to pay for borrowing cryptocurrencies are dynamically set according to demand, right? So if you go to compound.finance and you'll see the current interest rates, there is something like $15 billion worth of assets on Compound as of last night. There is about 5 billion worth of Ethereum that is available. So what it means is that there's a huge supply of Ethereum. People who own Ethereum, they're giving it to Compound saying, okay, let me try and earn some interest on it. Because there's a huge supply, the current interest rate for Ethereum is something like 0.08%, okay? However, you can also borrow other cryptocurrencies. So you can borrow a cryptocurrency called DAI. And when you borrow that cryptocurrency, you have to pay something like 4.5% interest on Compound. The reason for this is because there is a lot of demand for people who want to borrow this, which is known as a stable coin. So this is a whole another topic, but we'll talk about it later. So 1 DAI equals $1. So what is the whole point of this, right? And the other thing to remember is that this is over collateralized. So in order to borrow something, you have to deposit something. So what happens is, if I want to borrow, so a good example is I'm sitting on a bunch of Ethereum, but Ethereum price is very volatile. It keeps going up and down, up and down. It's crazy. Now I want to spend some of that money. How can I do it? I think that Ethereum is going to go up 2x in the next 6 months. So I don't want to spend my Ethereum, but I have a lot of money that is captured and sitting there. What do I do? What I can do is I can deposit my Ethereum to compound. I will earn a tiny amount of interest. But I can convert, I can then borrow DAI from compound on today's exchange rate between Ethereum and DAI. Okay. Then I can spend this DAI. I can do whatever, because one DAI is the same as $1. I can go and spend this DAI, use this money for whatever I want to do. 3 months later, I return the DAI. But in 3 months' time, what has happened is that Ethereum value in dollars has gone up 3x. But I get the same amount of Ethereum back that I had originally staked. So what has happened is that I've made the money in the appreciation of the Ethereum while being able to spend the money and make use of my cryptocurrency. So it is a bit complex, but the idea is that this whole thing can be mediated without a banker. It can be done without any sort of other intermediary. The interest rates are set automatically, and they're driven by the demand and supply of cryptocurrencies that are available. So this is kind of like crazy, mind-bending stuff, but there's a lot of material online. But you can see that this is one of the big reasons why there has been a huge leap in the use of cryptocurrencies in this DeFi space. We talked in the first slide itself. About the concept of money. Right now, interest rates are very low, so you don't really get yield. So people are getting into this DeFi space because you can get interest rates of 6-7% on your cryptocurrencies that you will not get anywhere else. Jitendra asked the question, how is price controlled for Ethereum, right? So the dollar value of Ethereum is based on a market. So the likes of, it's just like share prices or foreign exchange prices. The likes of Coinbase or Binance provide platforms where you can convert your cryptocurrencies into fiat money, into dollars or rupees. So it just depends on demand and supply. If more people are buying ETH and then selling, then the price of Ethereum in dollars will go up. If more people are selling, then the price will go down. So it is just it's just a normal market. There is no intrinsic value as such of Ethereum or Bitcoin or whatever. The dollar values that you see are completely driven by demand and supply. Okay, so that's just something to keep in mind. All right, let's. I don't want to take. Okay, so next, let's talk about NFTs. NFTs, as we said, are non-fungible tokens. They are unique digital assets. NFTs usually are, like I said, ERC-721 tokens on Ethereum. Now, because something can be stored as an unchangeable digital asset and can be moved from one account to another, this uniqueness can be used to determine the identity and ownership of an asset, right? So another thing to remember, when we talk about NFTs, it's not as if the actual asset. So NFT can be anything. NFT can be a digital picture like this CryptoPunks here. An NFT can be music, it can be anything. It can be any digital asset. The asset is not stored on the blockchain. The asset can be stored anywhere. An NFT basically says that this NFT, this token, is like a certificate. It says that Rushi, who owns this NFT, owns this digital asset. And that asset can be represented as a hash or can be represented in whatever way, right? These NFTs, it just means it's just a pointer saying that, hey, Rushi's account has this NFT, this token. This token points to Rushi's ownership to a digital asset. So, for example, I own the domain rushiluhar.eth, right? This domain is known as an ENS domain, an Ethereum naming service domain, quite similar to DNS. But this is basically an NFT. So what I own is a digital asset which says that, hey, Rushi owns this domain, rushiluhar.eth. Similarly, the example that I want to talk about in NFTs is this ridiculous, frankly ridiculous thing known as the Bored Ape Yacht Club. Okay, so what is a Bored Ape Yacht Club? It is a collection of 10,000 bored apes. So these two are bored apes. This is an ape which has some characteristics like its expression, like its clothing, headgear, its eyes, and so on, right? So what happens is somebody wrote a bunch of code that generated 10,000 unique images of these bored apes. Each ape can have more than 170 possible traits. These traits are captured and they are written down into your NFT. When you buy, when you get, or when you own a Bored Ape NFT, it basically means that you have access to the rights to this particular image. Okay, what happens is when these things are minted or generated, they are distributed to people, and initially each NFT costs 0.08 ETH, but then they can be sold and traded in a secondary market. So these NFTs started being bought and sold, and then this one, I think this one here, this one was sold for 769 ETH, or roughly $3 million. Okay, and what does owning a Bored Ape NFT get you? Well, you can access a website called the Bored Ape Yacht Club, and the more interesting thing is that what they guarantee is that in the future, any commercial use of this NFT is given to the owner of the NFT. So let's say tomorrow, Disney decides to make a Bored Ape superhero movie series like the Marvel Universe, right? Let's say there's a Bored Ape universe. And in the Bored Ape universe, Disney decides to make this ape, this one with a brown background here, as the main hero with the rainbow body or whatever. So it means that the owner of this NFT has a digital rights. Any money that Disney will give you to make a Bored Ape movie, you have the rights to it because your NFT shows that you own the digital right to the commercial usage of these NFTs. So this is kind of an interesting concept, of course, but it's also kind of crazy because the inherent value is nothing, right? This is just computer-generated art where each piece of art is unique. You have a pointer to the piece of art that is stored on the blockchain as an ERC-721 token. And then the owner of the NFT basically says that I can do whatever I want with this NFT, right? So it's a crazy world, but there you go. I recommend, yeah. No, so Rushi asked a good question saying, what happens if I generate the same image and get an NFT for it? So when you generate the same image and get the NFT will be different. The first one, I mean, anybody can actually copy and paste the image, right? There's nothing wrong with it, like nothing stopping you from doing it. But the idea, right, again, this is a public consensus. The idea is that the first one generated with the first NFT generated pointing to this artwork, that is the owner of the NFT. And to your point, Rushi, there is the NFTs for the same JPEG can be different because there is also an element of timestamping. When an NFT is minted, that means the first time that it's created, you have a timestamp when that happens, and then you have a pointer to the digital asset, to the JPEG, right? So you can always look at the NFT to say, actually, this is the first one, this is the original NFT, and it is uniquely identified. Okay, so that is how you can differentiate two NFTs that are pointing to the same digital asset. So it's frankly, it's madness in my opinion, but there you go. Okay, we are at time. I'm going to try and whiz through the rest of the slides quickly. Okay, so let's take a step back. We've kind of explored the crazy world of crypto. Let's take a step back. Let's think of it from an engineering perspective, right? So at the moment, the biggest mind share is in the Ethereum blockchain, right? So a lot of these things, DAOs, DeFi, NFTs, everything was pioneered on Ethereum. And because of the breakthrough idea of being able to model the Ethereum blockchain as a globally available virtual machine, right? But it has extremely serious limitations. The throughput of Ethereum is very, very slow because every execution of a smart contract relies on you doing a transaction on the Ethereum blockchain. So the more smart contracts you have, so the more people trading NFTs, the more NFTs being minted, it means that the blockchain gets clogged up with people trying to do transactions. So you just don't know, you cannot guarantee when your transaction will be done. It is kind of crazy. So the throughput is very slow. Now, because everybody trying to run a transaction on an Ethereum blockchain is also paying transaction fees. You're competing with everybody else who's trying to buy an NFT or buy an ENS domain or move money from one account to another. The transaction fees go up very, very quickly. So it's very, very high transaction fees. The tools are very fragile. The developer ecosystem is growing. It's Ethereum has the most mature ecosystem, but it's still very fragile. And the amount, if you look at YouTube videos, or if you look at material for how to build on top of Ethereum or learn Solidity, there is some stuff which is pretty good, but there's also a lot of BS, and these things change all the time as well. Okay, so I tried. I'm still trying to figure out how to write smart contracts and stuff, but there is actually a pretty steep learning curve. And as I mentioned, when you deploy a smart contract, your code is available to the world, right? So if your smart contract is doing something that is complex, then people can very easily find out holes in your code. So the penalty for failure is very high. Okay. The other thing, which is a little bit more subtle, is that code that runs on the blockchain can only ever refer to data that is on the blockchain, right? NFTs are digital assets on the blockchain. Ethereum or money on the blockchain only resides on the blockchain, right? Any smart contract can only refer to data that is already present on the blockchain. Now that is, so in order to do something with data coming from the outside world, you have to rely on somebody providing that service for data that is coming in. So there are a bunch of different ways in which you have to get data into the blockchain. So there's something known as price oracles, right? So for example, Compound, right? The DeFi thing that we talked about. How do you actually know what the value of different cryptocurrencies is? How do you actually know what the dollar value of different cryptocurrencies is? So they need to actually have a price oracle, some way of piping in the exchange rates from outside of the Ethereum blockchain into the Ethereum blockchain, which again opens up for a lot of abuse. So it means that somebody can spoof a market data feed that is coming in, and you can cause all kinds of chaos, because suddenly you might say that the price of some crypto has collapsed, and that because everything is set algorithmically, interest rates might suddenly change. You might end up having margin calls, all kinds of craziness, because somebody have spoofed the market data feed through the price oracle that is going into your protocol. Okay, so this is, all kinds of fun stuff can happen here. Okay, Nandan says, right now we can update our application through upgrading versions. How can this be achieved when building applications on top of Ethereum? As something once deployed, yeah, so it's a great question. So they also have to do some sort of versioning, and then you have to have some sort of consensus which says that this smart contract is no longer valid. You need to point to another smart contract, which is the new version of your application. It is not an easy problem to solve. But there are obviously workarounds. But what it means is you need to run a transaction which basically says that this version is deprecated, and then now you have a new version. Okay. So my conclusion, this is of course very, very subjective. The first question that I ask is that, okay, what is the point of having decentralized applications? The characteristics of the applications that run on the blockchain are very specific, right? So you need to kind of think about what is do you really need to have code that runs publicly? Do you really need to have something done in public? What is the reason why you need to actually have a decentralized application? I don't think that a lot of the things that these guys are building, there is a compelling reason to have that. The other the other point is that what are we competing against, right? Decentralized applications are competing against things like cloud computing, relational databases, existing software infrastructure, which is battle tested, which has been around for a long time, and it will have much better performance than anything that you can put onto a blockchain, right? So you need to think very carefully about, okay, what is the point of having a decentralized application? Do you really need it? Similarly, even within the crypto world, there is a split between people who just want to use crypto as a digital gold, like Bitcoin. So if you follow Bitcoin maximalists, right? So these guys will say that Web3 is BS. The only thing that is important is Bitcoin. So we don't know. There is still a little bit of philosophical discussion happening here between using crypto as purely a store of value versus using crypto as a way in which to build application. The environment cost, especially of proof of work, is incredibly high because you have a lot of repeated computation that goes on, and it just keeps getting more and more complex because of the way that these protocols are deployed. So Deepak mentioned that he has explored hash graphs. Are they better than Ethereum in practical usage? Actually, I don't know what hash graphs are, Deepak. Thank you for bringing them up. I'll take a look. In general, the whole USP of a bunch of these new blockchains, Algorand, Solana, Avalanche, is that they claim to be a lot more efficient with much lower transaction fees than Ethereum. But honestly, until you have a big enough developer community and you have enough people willing to run nodes on these networks, the viability of building stuff on these networks is open for debate. I actually don't know what hash graphs are. Let me know what they are. I would love to find out more. Okay, so yeah, there's a huge amount of hype. I think anybody who follows tech news knows what this is. I mean, seriously, I mean, this thing sold for $3 million. I mean, that's unbelievable. Okay, there's also lots of hustlers. There's a lot of fraud that happens in this space. So think about it. So, what is the actual killer app? Maybe distributed finance is something that the ability to do transactions. That might be something of interest, but that is still open for interpretation. But the truth of the matter is that it is actually a lot of very interesting technology. There is a lot of very smart people who are working on developing and thinking about developing protocols, trying to think through how to use this way of working to build interesting applications. So although I'm very skeptical about a lot of the hype that is going on today, however, I still think that for a subset of what we're talking about right now, there might be pretty compelling applications. And so it may not justify the multi-billion, hundreds of billions of dollars that are going into crypto right now, but I think there might be something there which we'll find out in the next couple of years. Okay, so when people ask me, should I get into crypto? I think it is a great time to learn and figure out. It's a really good way of learning behind some of the mathematical and software engineering concepts that underpin crypto. It is amazing to learn about the type of applications that are being built. And if you want, you of course you can also look at it as a part of your investment portfolio if you're looking at it as an investment. But as I said, don't bet the house on it. That's at least my advice. So this is, of course, a comic from XKCD, and the question is, should your project use a blockchain? And well, you can see what the answer is here. So that pretty much is what I wanted to cover today. I know we're over time here. Thank you for your patience. Thank you for listening to me. Thank you for those who ask questions. And Deepak, thanks for the link to Hashgraphs here on chat. I have a few minutes if anybody wants to ask any other questions or bring any other project that they have done to light to share with me, or if you want to share with this group here, please go ahead. But otherwise, thank you all very much. If there is interest into diving deeper into any of the topics that we've discussed here, I would be very open to doing a more focused discussion that we can we can maybe even do some sort of seminar type thing, some Q&A session. Rajendra mentioned that there is something called Hyperledger. Yes, yeah, Hyperledger is also another way. Again, I don't know the details of it, but actually there's a whole bunch of different concepts that are there. Hyperledger has been around for a while. There's also something called the Internet Computer. This kind of takes the notion of a distributed computing mechanism and tries to make it more like the computers that we know. There are a whole bunch of people that are doing a lot of very interesting work. I mean, there's also one of the things that I didn't cover here is there is this notion of layer 1 and layer 2, right? So layer 1, so one of the big issues with Ethereum, with Bitcoin, is, as you said, the slow transaction processing, high transaction fees, and so on. So what a lot of projects have done is to say, look, we want to still use the Ethereum blockchain, for example, as a backbone, but we will do the computation away from the blockchain, right? So this is known as a layer 2 protocol. So what happens here is that the smart contract is not deployed on the blockchain itself. It is actually deployed outside of the blockchain, but the blockchain is only used to store the results of the computation. So the layer 2 protocols, good ones to look at, actually coming out of India, I believe. It's called Polygon, and their token is Matic. Polygon is a protocol that has come out of a bunch of guys in Bangalore, I believe, Bangalore, Hyderabad. But this is a layer 2 protocol, and they are coming up with ways. It runs actually on Ethereum, and they're coming up with ways in which you can remove some of the bottlenecks around transaction processing on the blockchain by doing some work off chain and then just using the blockchain as a store of the results of the transactions, right? So there are a bunch of layer 2 protocols. Layer 1 protocols are the ones that we've kind of talked about. We have Solana, Algorand, Cardano. Sorry, I don't know about the spelling here. Okay, there's a whole bunch of these that are around. For those who want to understand a little bit more about the philosophy behind these protocols, I would suggest looking up the Lex Friedman podcast on YouTube. He has a bunch of interviews with the likes of Vitalik Buterin, with the guy who was behind the Cardano protocol. He really goes into, these podcasts can be hours long, but they actually go into a lot of detail about how these things work. It's a good way for a layperson to try and understand the philosophy behind a lot of these crypto projects. Okay, so Rushi Tucker asked about owning service tokens. There was news about push notifications for Ethereum tokens are offered. I'm not sure what that means, but yeah, we can find out. I'm actually not sure what service tokens means. Like I said, this environment is moving very, very fast. There's a lot of different things that are there. So who knows what's going to happen. I would gonna finish this meeting in a minute. If you want to look at some links, I would definitely recommend this link here, which is a skeptical take on building on the blockchains. And then I would also strongly recommend this link here, the architecture of a Web3 application. This is by Preeti Kasireddy. She is a really good communicator on a lot of these technology protocols. She kind of compares a Web 2 application stack against a Web 3 application stack and talks about the differences and similarities between the two. Probably the most vocal person in this space from an investment and philosophy perspective is called Chris Dixon. Chris Dixon works for Andreessen Horowitz, VC that has gone has done significant investment in the crypto space. He has these theses about why he thinks decentralization matters. It's worth a read. Multicoin Capital is a hedge fund. They do a lot of writing in this space. They have made a ton of money in the crypto space. This is a pretty technical article, but it talks about distributed finance and how it works and how it will evolve, and so on. And of course, you can probably see what the tenor of this link here is. Okay, so I have a lot of other material. If people are interested in any other specific topics, do let me know. I'll just conclude this this presentation by saying that it is an evolving space. Please don't bet your house on crypto because it is a very volatile space. You will probably end up losing a lot of money. So having said that, thank you all very much. And if you have any questions, I am around. You can find me on Slack. You can email me. The material is available on the Slack channel. Thanks for your time, and have a very happy new year, everyone, and wonderful and fun 2022. Who knows, maybe we'll do some crypto work at Jeavio. We'll take it from there. Thanks, everyone. Bye-bye.